Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on other technologies. Let's start our part 2.
Now it's time for us to look into the QoS topic. Now QoS topic is quite important in your exam. Alright, so over here I will just introduce you some of the QoS concept. So we are going to look into the overview of QoS. Priority mapping, so we are going to look into the type of service, IP precedent or DSCP. We are going to look into the concept of policing and shaping, the differentiate between them. What is congestion management, congestion avoidance, and finally in the QoS we also will look into the traffic policy. Alright, so first let's look into the QoS. Alright, now QoS is very important when we use our network, primarily because that the application that we use do have a different type of requirement in terms of priority. So QoS kick in to give us different type of priority. So this is where we have a differentiated service. QoS improve the service quality through indicator such as the bandwidth, delay, jitter, and the packet loss ratio. Okay, so this is where the QoS is important. So do we want to maximize the bandwidth, or should you use the application where the low delay is important or the low jitter is important? Okay, so that will be provided with the QoS mechanism. Now before we look into the QoS, we look into different type of service model. Now the first one is a best effort. Now best effort is the default model in our network. Best effort basically means that there is no QoS. Whichever that is actually come first, you will let it to go first. There is no concept of priority, so this is what we call the best effort. Alright, so that is the default. Now another model that we have over here is integrated service model. Now integrated service model, as its name suggests over here, is actually part of the network. Example of the integrated service model is RSVP, okay, or reservation. Now RSVP allows us to reserve the bandwidth for certain application. Now RSVP is good if let's say you want to guarantee that you have sufficient bandwidth for certain application, but the disadvantage is because of the scalability, which the last model here overcome the problem of integrated service. We call it as differentiated service model or DSCP code point. This is where DSCP will be used in the differentiated service model. Now in your exam, you will be focusing on the differentiated service model rather than the integrated service model. Okay, so let's just look into how we can do the port priority first. Now for us to have different type of priority, the first thing that we need to do over here for the QoS is the ability to mark the packet, and that function is on this particular field called type of service field. Now type of service field have 8 bit. Alright, that is from 0 to 7, so that's exactly 1 byte. So inside the byte over here, we consist of the value. Okay, so this is bit number 0 all the way to the bit number 7. This is the type of service. Now on the IP precedent, so here if you are using the IP precedent, we only use 3 bit, which is bit 0, 1, and 2. So basically we have 2 to the power of 3 will give us 8 type of combination. So if you are using IP prec, you only have 8 combination, which the value from 0 to 7. Now another model that I mentioned earlier on, alright, that I mentioned here is a DSCP, differentiated service code point. Now differentiated service code point, you notice that they are using up to 0 to 5. So in this case we are using 6 bits. Okay, now the 2 bit behind over here is unallocated, so we don't use this 2 bit behind. Now if you look into the earlier model, which is type of service, they are using altogether 8 bit, 0 to 7. Okay, so the first 0, 1, and 2 bit, okay, so that will give us the priority. Bit number 3 will give us the delay. Okay, bit number 4 will give us a throughput. Number 5 is a reliability. Number 6 is a costing. Number 7 is not being used because this is a chat bit. Okay, now type of service we don't use nowadays because right now we are primarily using a DSCP. Now it's important for us to look into this field because when we want to give different priority, the first thing that we need to do is to do a marking. It can be marked based on IP precedent or it can be marked based on DSCP. Now before we look into QoS in detail, the first thing that we need to learn here is a token bucket, alright, or we call that as a TB. Alright, this is important in the later part to understand how the traffic shaping and the traffic policing work. Alright, first we are going to look into the single rate, single bucket. Now firstly, what you can see on this diagram is that we have the CIR. CIR is called committed information rate. Committed information rate. Now the committed information rate is the rate that the token go into your bucket. Okay, that is the rate typically that you subscribe from your service provider. Let's say now you subscribe a 1 megabit per second, so that will be your CIR. Alright, that you are allowed to use 1 megabit per second. Now whereas we have the CBS or committed bus size, this one is in terms of byte. Okay, that is to say that how big is your bucket. Alright, so now you know that what is a CIR and what is a CBS. Okay, so token bucket determine whether the traffic exceed the limit and enforce the adjustment policy. Now how am I going to know that whether the traffic is exceeding or not? Firstly, you have your CIR. Next, you have your packet. Now whether the traffic is exceeding is that if let's say my B, which is the rate at the user use the traffic, is more than my CIR, alright, if let's say that's the case, then I know that it's already exceeded the limit. Now if it's within, if it's a B less than the CIR, that means that it doesn't exceed my limit, it's still within the limit. So that is where the CIR become very important. Now you notice that if the B, which is the rate that I'm using it, is less than or equal to the TC, which is the token CIR, then if it's okay, that means that this is still within, is conform. Or anything above it, if let's say my B is more than CIR, that is a violate. Normally, packet that is violate will be dropped. So now you understand the concept of committed information rate, committed bus size, the packet, and the formula. B must be less than or equal to a TC for it to confirm, else it will be violate. Now this is where we have a single bucket. So this is a single rate, 1 CIR, we have a single bucket. Alright, we also will look into the single rate dual bucket or dual rate dual bucket. Next we look into a single rate with a double bucket. So here we have the CIR. You notice that this diagram over here, if we look into this part here, is exactly identical to the earlier one. Now the difference over here is instead of just CBS, we have the EBS. Now EBS is excess. That means that anything that is overflow. Now you notice that, let's go back into this earlier diagram where I have a single bucket and single CIR. Now if let's say you are not using any packet at all, so my CIR will be keep on flowing into the bucket. So that token will be overflow. Now those overflow token will be lost. Okay, this is where we are using the CBS, which is one rate, one CIR, and a single bucket. Whereas for the single rate double bucket is that I still have a CIR, let's say 1 megabit per second. I still have the CBS, but anything that is overflow will be go into the excess bus size. Now the concept is identical except that if my usage is less than or equal to my CIR, that is conform. But if it's not, then it will go into the EBS, which means that do I still have any access in this EBS? If I do have access, okay, you notice that if the B is less than or equal to the TE, then it's exit. Now if let's say here I also have empty bucket, this bucket is empty, then it's become violate. Now this is a concept called a single rate double bucket. Now another type that you can use is called double rate and double bucket. Now as you can see from this diagram, you can see that I have a PIR, stand for peak information rate. Alright, the CIR as is the normal CIR. Now the peak information rate is mainly used for burst. Okay, and here we are going to evaluate the traffic based on color, and we have three color here: violet, exit, and conform, which is red color, yellow color, and green color. Okay, so color over here evaluate the result. Okay, red is violet, yellow is exit, and the green is conform. Now let's have a look into this mechanism. So instead of a single rate, now I'm using dual rate. Now the PIR rate must be larger than your CIR rate. Okay, now let's say your PIR is 2 megabit per second and your CIR rate is 1 megabit per second. Now if let's say the packet coming in as 1 megabit per second, okay, so the first thing that it will evaluate is that is your packet that coming in is more than your TP, which is your PIR. No, because I'm using 1 megabit per second, so it is not violate. So is it exit? No, it's exactly 1 megabit, so it's conform. Do you see that? Now let's assuming that now it's not 1 megabit, but this time it's 1.5 megabit per second. Now when it's come into this B is 1.5, TP is actually 2. So this is not violate. Okay, so we are not under the violation. So we go into this bucket. So 1.5 is more than 1. That's true, yes. So in this case, this traffic will be marked as yellow. But assuming that now I'm actually coming in as 3 megabit per second. Okay, so now the rate that you are using is exceeding your PIR because your PIR is only 2 megabit per second. So in this case, it's violate. Okay, so I mark it as violate, but I still can have my bucket size over here. That is your PBS. So you need to know that we have a single rate single bucket, we have a single rate dual bucket, and we also have dual rate dual bucket. Okay, so these are concepts you have to aware first. Now let's look into the traffic policing now. Okay, so what is exactly called traffic policy? So traffic policy allow you to evaluate the traffic volume. So this is my data stream using a token bucket and a discard access traffic to limit the traffic within a specific range. Now for example, if I'm going to do a CIR of 1 megabit per second, so which means that only 1 megabit per second on my CIR will allow to pass through plus my CBS. Remember that this is my bucket size. Okay, so this size is in byte. Alright, so this is in bit. So the result will be either you are allowed or you are going to be dropped. Okay, or you can actually do a marking. If you still remember that we have a red, yellow, and we also have a green. Okay, so green basically means that you are conform, you are allowed to pass through. Okay, or the action can be dropped. Now for me to demonstrate this, I'm going to go into my ENSP and show you how you can configure the traffic policy. And basically there are two ways for you to configure it. Either you can use a QoS car or you can use a QoS line rate LR. Okay, let me jump into the ENSP and show you the configuration. Now to demonstrate the traffic policy, I'm actually using three routers, R1, R2 and R3. Now all of these are belong to area 0 or SPF. Okay, so let me jump into my CIR. Alright, so my command line. Okay, so let's do a interface brief. Okay, so as you can see that I have my physical interface, which is 10, 12, okay, 0, 1 here, and I also have a loopback. So the rest is as label. So I'm going to do a trace from my loopback to a loopback on trace. So I'm going to do a trace -A from my loopback. I want to go to router 3. As you can see that my OSPF, it does work. It's actually go to 12.02 and then landed into destination of 23.03. Now I'm going to configure the policing in the router 2 and to show you the effect of the policing. Now before I do the policing, I'm going to do a test. Okay, let's say I'm going to test 100 packet with a source of 1.1 with before that I'm going to change the size to 1000 byte, okay, with a source of 111 and the destination of 3.3. Now this is before I have any policing. As you can see that if I'm going to do 100 packet of the ICMP ping, I should have no problem. Alright, so while that is doing the ping, I jump to router 2. Now in router 2, I'm going to do a policing, alright, on the serial 100. Now let me show you the interface of serial 100 here. Now as you can see that the bound rate of the speed is actually 64,000 bit per second, 64K basically. Alright, 64K is my bandwidth on my serial interface. As I mentioned earlier on that I do have two different commands. One is called QoS car, another one is called QoS line rate. Okay, now the difference over here is that the line rate can apply to any other protocol, not only for IP packet. Now let me show you one by one. Before that, let me show you here. Okay, you can see that it's 100 packet, 0% drop using using 1000 byte as my ICMP. No loss over here. Okay, so I'm going to do a LR line rate first. So first I'm going to go into my serial interface. I do a QoS LR. Okay, let me show you. That is my line rate. Okay, as I said that there are two commands that you can use, either a car or line rate. So I'm going to use a line rate. And in the line rate, they ask for the percentage. As just now as mentioned, the serial interface here, the interface here having a 64K bandwidth, okay, bit per second. So the percentage allowed me to use anything from 1% to 100%. So assuming that if I'm going to use 1% of the 64,000, it will give me about 6,000. Sorry, so this is a 64,000. 10% is 6 kilobit. So that means that 1% is 600 bit per second. That is very, very low. Okay, so I'm going to use 1%. All right, that will be less than 1 kilobit of traffic. All right, so you also have an option to specify your CBS, which in this case, the size of the bucket. So the bare minimum that I can have is 1005, so I'll just use the bare minimum. So basically with this value, practically on your serial link, you don't have much of the usage over here because the percentage is so low. But anyhow, let's test it out. So I go back to router 1 and I'm going to do the same test again and see what really happened. Right, so you can see that over here when I do a ping using a size of 1000 byte, it really doesn't actually have much of the effect. Okay, there's one timeout here. So it is not fast enough to saturate it because the size of my bucket is 1005. Alright, so not much of the problem here. So what I'm going to do is I'm going to increase the size over here to 1005 and see what will happen. Right, now straight away you notice that over here you can see that the latency is pretty high. All right, and you can see that I also have a dropping. Okay, now I already exceed the size of my bucket. All right, remember that the bucket size is exactly 1005. Now please remember that I do have some overhead as well, so that indicate that the packet is actually lost, and that also telling me that there's a lot of delay, as you can see from here. So if I do a display interface serial 100 and I'll look into my actual input, you can see that the byte rate over here is only less than 1 kilobyte. Is basically is 600 over byte. That's an average. Now it's actually jumped to 700 over byte per second. Okay, so it looked like our line rate here, it does take effect. Okay, that is about 1% of my percentage. All right, that actually show you that the policing is in effect. Okay, let me stop here. Okay, and you can see that the packet loss is quite significant. So let me remove this and see what will happen. Undo QSLR, and just to show you here, once I remove, I should have no problem. As you can see that is the line rate, pretty straightforward. Okay, now the second command I'm going to show you here is the QoS car. Now when you do a QoS car is a committed access rate. You can apply it for inbound and outbound. So since I apply to the serial 100, I'm going to apply it into the inbound. Now you have an option compared to the line rate, because this one is based on the IP. You can actually base on destination IP or source IP, or you also can base on ACL as well. All right, so over here I will just base on CIR. Okay, the committed information rate. If you still remember earlier on, I told you that we have our committed information rate. That is the rate that you're allowed to be policed. So assuming that now the CIR here, you can see that this is in kilobit. I'm going to do a, you can see that the bare minimum is 8. So I'm going to use 8, the bare minimum. Then I'm going to specify my CBS. Again, it's 1005. Now you have the option to change to dual rate. Okay, so that is a PBS. So assuming that I do not want to do a PBS, what will happen then? You can see that it gives me an error. So in this case, you are going to do a PBS. And what's the bare minimum for PBS? All right, so your PBS, in this case, your peak bus size is in byte, so it's 1005. So we have to specify the bare minimum. Now here, this is your marker. You can mark it as green, red, or yellow, or you can just execute it. All right, so let me do a display this. You'll notice over here, this is a QoS car with 8 kilobit. CBS is 1005 and PBS is 1005. And you also notice that we have a green is pass. All right, we have the yellow that is pass, and that is a red that is discard. Now this is by default. Definitely you can change it if you want to. Now I'm going to do a testing one more time. Okay, and see what will happen. So you can see that it's time out. All right, that is 1005. You can see over here that I'm using 8 kilobit per second. The CBS is 1005, PBS is 1005. Now let me reduce the size from 1005 to slightly lower. Okay, let me use 1000. Okay, so as you can see that once I reduce the byte to 1000, you can see that I have one timeout. For every 2 ICMP, I have one timeout. All right, so let me look into my throughput over here. So let me do a display interface serial 100. Okay, so you can see that there's about 620 byte. Okay, that's my input. 600, 589, 589. Okay, so that is again the policing is in action. So rather than using a percentage, now I'm actually using a CIR. Okay, so this is the command. Okay, and this is the effect when you do a policing. So if I'm going to reduce further, okay, because 8 kilobit per second is just too low. So if I'm going to do a 100 byte and see what will happen, as you can see that there's no issue. Alright, because now it's confirmed. Right? So that is our policing. Now let's just go back to the router 2 and I'll show you another command here. It's called display QoS car statistic. So I'm going to specify my interface of 0000 in the inbound. Okay, now as you can see from here, this is the number of packet that is being dropped, the number of packet that is being passed, and this is a green, there's no yellow, and it's either allowed or it's get denied. Okay, and out of this 30 packet, 37,336 byte is being dropped. Okay, so this is another command that is to indicate that my QoS car is in action.
Thanks for watching. Please do not forget to subscribe to our channel.